Let's take a look at U-substitution today. The idea behind U-substitution is to try to do the chain rule backwards. So let's take a look first of all at one we might recognize. How about this? 2x cosine of x squared dx. Now, if you're thinking about an antiderivative, you want to say this is the result of doing a derivative. What did we do a derivative to, so to speak? Well, the 2x looks like it probably came from a chain rule on an x squared thing. And the cosine would have come from a sine, because the derivative of sine is cosine. So I would think that this antiderivative might be sine of x squared plus a constant. Let's check. The derivative of the sine of x squared, well, the derivative of sine is cosine, so that's cosine of x squared, and then times the derivative of the inside function. The derivative of x squared is times 2x, which would be 2x times the cosine of x squared. And of course the derivative of a constant is 0. That just drops out as always. So we got lucky. We noticed that this looked an awful lot like the chain rule being applied to the sine of x squared function. Sometimes it's harder to see where things came from, and the whole idea behind a U-substitution is to try to keep track of what happens to this constant here and things like that when you apply a chain rule backwards. Let's take another example and see how we systematically work this. Let's take a look at the integral of, this time instead of having a 2x, I'm just going to have a plain old x, and then I'm going to have the square root of x squared plus 1 dx. Okay, this time again, the chain rule coming from x squared plus 1 probably produced the 2x on the outside. Well, there isn't a 2, so we'll have to fix that. Here's the procedure. I'm going to take this inside function, it's inside the square root. I'm going to call that u. I'm going to let u be a function of x. And then I'm going to need to know what the derivative of u is. In other words, what's the derivative of this function going to look like, this inside function, when it shows up outside? So du dx would be 2x. And then we'll play around a little bit. I will cross multiply by the dx and divide by the 2, so that du divided by 2 becomes x dx. Okay, now we're ready to do the substitution. Where I see an x squared plus 1, I'm going to put a u. Where I see an x times dx, I'm going to put in a du over 2. And what we always do is we pull the constant out of the antiderivative and stick it in front. So this becomes the integral of, and again, the square root of u. The x dx becomes du over 2. I'll write the du here, and I'll write the over 2 on this side. Therefore, this is 1/2 of the integral of u to the half du. Now we apply the powers rule to u to the 1/2. So we get 1/2 times u to the 3/2 over 3/2 plus a constant. Invert and multiply, cancel the 2's, we get 3 times u to the 3/2, u to the 3/2, I'm sorry, over 3 plus a constant. U was x squared plus 1 originally, so we want to go back and put the x squared plus 1 where the letter u is. This gives us then x squared plus 1 to the 3/2 over 3 plus a constant. Let's stop there for a minute.